Hi guys, welcome to our video lecture series of Laplace transforms. So we are discussing Laplace inverse transforms in our lectures, and we talk about some properties of inverse transform in previous lectures, and we will continue after having some revision that Laplace inverse transform of a function f of s when divided by s is simply equals to the integral of 0 to t Laplace inverse of f of s dt, or we can write it as 0 to t function of t dt, where the function of t is simply Laplace inverse of f of s. So we learned and we solved some questions about this property, and property number 2 was Laplace inverse of a function of s multiplied by s, that is equals to the derivative of function of t plus the value of function of t at 0 multiplied by delta t, where f of t is just equals to Laplace inverse of function of s, that is this function of s. So now we will continue our lesson and we will talk about the shifting properties of Laplace inverse transforms. So we know that Laplace inverse of function of s is equals to the function of t. So the shifting property says that the Laplace inverse of some function of s plus a is equals to e raised to the power negative at Laplace inverse of function of s, where the function of s is simply when we remove this a, so we will left with function of s, and this a is shifted to this exponential. So we'll take some examples, we'll solve it, and then we will understand it perfectly how to solve these type of problems. So we are given with a question 1 over s plus 2 whole powered 5, and we can see that if we compare this with 1 over s plus a power n, so we can see that n is equals to 5 and a is equals to 2. So from the shifting property we can say that e to the power negative 2t, and then Laplace inverse of f of s. But what is this f of s here? So f of s is simply, after removing 2 from the bracket, we will left with 1 over s power 5. So our function of s in this case is 1 over s plus 5. I have to take the inverse transform of this function, so e raised to the power negative 2t Laplace inverse of 1 over s power 5. And from the table of Laplace inverse fundamental functions, we know that 1 over s power n is equals to t power n over n minus 1 factorial. So it will be equals to e raised to the power negative t multiplied by t to the power it's n minus 1, so it will be t to the power 4 divided by 4 minus 1 factorial, that will be equals to e raised to the power negative 2t multiplied by t power 4, or that is 5, 4 factorial. So the Laplace inverse of 1 over s plus 2 whole powered 5 will be simply t power 4 e raised to the power negative 2t divided by 4 factorial. So that is the answer for this question. Now we will take another question, another example, that is question number 2. Let's say the question is 1 over 9s squared plus 6s plus 1. Now first of all we have to arrange this question, and we have to make the order of the question. So I can write this question as 1 over 3s whole squared plus 2 multiplied by 3s plus 1 multiplied by 1 plus 1. So this is simply 3s plus 1 whole squared. So I can simplify this function. So 1 over 3s plus 1 whole squared is equals to 1 over 9 multiplied by s plus 1 over 3 whole squared. What I do here is I take 3 as a common by 4, so here I have to divide it by 3. So it's when 3 comes out of the bracket, it's 3 squared 9 and s plus 1 over 3 squared. Now I will compare this s plus 1 over 3 with 1 over s plus a to the power n Laplace inverse, and we can see that n is equals to 2 and a is equals to 1 over 3. So I can shift it as e to the power negative 1 over 3t Laplace inverse of, when I remove this 1 over 3 I will left with s, so I can write it as s squared. So that will be equals to 1 over 9. 1 over 9 is at its place, and e to the power negative 1 over 3t multiplied by, now the Laplace of 1 over s to the power n is equals to t n minus 1 over n minus 1 factorial. So it will be equal to t to the power 2 minus 1 over 2 minus 1 factorial. So the Laplace inverse transform of 1 over 9 s squared plus 6s plus 1 will be equals to 1 over 9 t e to the power negative 1 over 3t. So I hope you understand these questions and examples for the ease in the future. So you may take some other questions and you can solve it. So this is all for the time being, and we will come up with the second shifting property in the next lesson. Thank